Hello, welcome to lab number 5 for Physics 2211, in which we're gonna create our own capstone project by taking any lab of our desire. In this case, I decided to go back to lab 1, in which we studied the constant velocity of an object. However, I wanted to take into account angles, so we're gonna study the constant velocity of an object moving down an inclined plane. The main objective for this experiment is to observe the motion of an object that is moving down an inclined plane, in this case a ramp, and the object is moving at a constant speed. We take this video and we analyze it through Tracker and we compare it to the computational model created through GlowScript. So the object that I decided to use was a lampshade, which diameter is of 0.16 meters and its mass is of 0.072 kilograms. Now, the fundamental principle. The basis of this experiment lies behind Newton's second law. And because we are using angles, we have to take into account SOHCAHTOA, which we actually didn't touch in any of our labs, so I thought it was a very nice idea to incorporate it in this lab. So we know that Newton's second law, going back to week number 1, the final velocity of an object equals the initial velocity plus the net force divided by the mass multiplied by the change in time. Now, what's most important here is the angles. So we know, as you can see in the image to your right, we know that the sine of an angle equals the length of the opposite leg divided by the hypotenuse. The cosine of an angle equals the length of the adjacent leg divided by the hypotenuse. And the tangent of an angle equals the length of the opposite leg divided by the length of the adjacent leg. So in this case, we're just going to use the sine and the cosine formula to calculate our changing velocity in the x direction and y direction respectively. Now, when we obtain the data, we use Tracker. So here is the video. Now, as you can see in the video, the lampshade rolls down the incline plane. So this video was inputted into Tracker, and we have to your left the main values that we took from Tracker and we inputted in our code. So we have our initial frame of 80. We did not use the initial frame 1 just because the video was lagged and we needed to take the point in which the object was at rest to the point that it started moving. The change between each time frame is of 0.033 seconds. In order to get R2, which is our second position, is the difference between our initial position, which we know it's 0, and that second position, which we're going to use and divide it by the time to get our average velocity. In order to get the speed, which in this case we will count as our hypotenuse to calculate our change in velocity, we take the average velocity divided by time and we get that the speed is of 0.355. And now to get the change in velocity, we just take that magnitude and multiply it by our cosine and our sine respectively, making sure that our y component is negative because we're moving down the y axis. So now, taking all these values and putting them into GlowScript, we created our computational model. So as you can see here, we have the main things that we changed in our code. So we started off with the mass of the object, the ball's velocity, which is basically the vector that we just calculated in the slide prior to this one. We also have the change in time, which is the change between each frame. And this is important. Our t, we did it all the way to 2, not the last time that was expressed in Tracker, just because we wanted the model from our computational model to show the displacement that we had in our video. We also have our updated position and our updated velocity. So now the most important part, comparing our data. So first of all, here we have an image of how the computational model looked like, which is basically the movement that the object had from the beginning of the ramp to the end of the ramp. We also see that we have a constant velocity and our position graph increases because we're moving into the positive direction of our x-axis. Now comparing both Tracker and GlowScript, blue being Tracker and orange being GlowScript, we can see that in Tracker we have a curve, and this is because the points that we choose as our changing position were done manually versus the points that the computer chose were perfectly distanced. So we see a more direct and a bigger slope like the one in our computational model for GlowScript. And for our discussion, we know that this experiment was a very basic one. However, it has a basis for every other experiment that we've done in this class. We know that we didn't use any net forces. However, we could have taken into account gravity and the contact force as our net force. Also, the main difference between each of the slopes of the graphs lies in the inaccuracy of selecting the positions. And we know that if we would have done this experiment and taken the difference between time and the y-axis, we would have seen a concave down curve. So I hope this experiment was helpful and allowed you to understand constant velocity with angles. Thank you.